أيوة خلاص. So to make it fast, we'll start with Yves Poppe presentation, please.
Thank you. We'll make it in 8 minutes so that Mohamed can get his special award and we will all contribute. So the team Network Exascale Supercomputing, all of you know what supercomputing is. ASTREN, first of all, is the agency for science, research and networking in Singapore. And we had to solve one problem, was to maximize throughput between two sites. It sounds easy, but it's not always trivial. And the two sites in question is Fusionopolis and Biopolis. One side has the computing, other side has the storage. As you all know, supercomputers are constituted of cores, and the cores talk to each other using a protocol called InfiniBand. And on top of that, you have a protocol called RDMA, Redirect Memory Access, which is a kind of a bus analog, and that's the magic potion of supercomputing. Now, in the early days of InfiniBand, you could reach a maximum of 18 meters with InfiniBand, and here we wanted to do InfiniBand on 2 kilometers. Now, two major suppliers in the InfiniBand world. There's a company called Mellanox, and the other one is Intel. And between the two, they basically share that market. So we started. So here is our data center. It's on the 17th floor, which is quite unique because you have to bring power up to the 17th floor, but that's another affair. And we have to connect it to Biopolis. So we tested that for about 2 years. And it worked. In fact, we tested with Mellanox, and then we discovered a little box which can go further than the Mellanox box, and which happened to be developed for the US Army for a remote visualization. And the product was developed by a small Canadian company, surprise, surprise, called Obsidian, who we discovered at the ISC, the European Supercomputing Conference in 2013. So the rest is history. Today, the two sites are connected at 80 gig, and we are very happy with the results. Now, there is another idea behind that, and that's the NSCC, the National Supercomputer Center. And that was, in fact, approved by the minister in Singapore 2 weeks ago. Goal of NSCC, we get a budget for 2 petaflop machine, not exaflop yet, and part of that budget is international connectivity to the US, to Japan, to Europe, and we also hope, of course, to the HOX here in the Middle East. Now, to continue, some of us know that TCP has a curse. It falls apart when you go higher speed. We will not go into these details. You know all of that, and we want Mohamed to have his bonus. So InfiniBand is the magic potion with RDMA. RDMA has undeniable virtues. I think the presentations will be on the website, so you can read it, if you're interested, of course. The HPC road to InfiniBand, as you know, the high power computing has a kind of Academy Awards 2 times a year, where they have the top 500 in HPC. The current top one is a Chinese machine called Tianhe, which has 33 petaflop. Then you have Titan from the Oak Ridge National Labs, et cetera, et cetera. So these are the fastest one. Now in 2003, practically nobody was using InfiniBand. Everything was other protocols. Today, at November 2014, a couple of weeks ago, 225 of the top 500 are using InfiniBand. And in fact, amongst the major suppliers, IBM uses InfiniBand, and HP, who had their own protocol, also just announced they're embarking on InfiniBand. So it seems to have wind in the sails. So of course, our choice is InfiniBand. Ultimate jailbreak is again that you can go very long distance. And that's where the thing started to be interesting, because it proves itself in a spectacular way. The NASA tried it out between two sites. Effective throughput on the same 10 gig link was multiplied by a factor of 30. We couldn't believe it. We thought it was some kind of snake oil. So we decided we should try these things. And we did that at Supercomputing 2014 in New Orleans. We set up a 10 gig connection from Singapore to the US West Coast, plus 100 gig, which was given by Tata Communication with the CenturyLink prolonging the 100 link to New Orleans. That was the topology. The second layer is InfiniCortex, and that's the contribution of A-Star, because we want to have a supercomputer of supercomputers, and in this context, we developed new algorithms to have that. Now, the four elements: very high speed, InfiniBand over trans-Pacific distances, the famous galaxy, and of course, you need applications. This is the famous box made by Obsidian for the military, which has inline encryption, by the way, and there's also now a version which is called the Crossbow, which will allow switched InfiniBand, and that's the next thing we're trying out. It goes with the different topologies. Galaxy is there. I will not bother you with the advances. That's Professor Yufeng Deng, who works for us and is also a professor in the States, and he developed these algorithms. Now we are making the vision a reality. As I mentioned, we tested and completed within Singapore. We tested with Japan, with the Tsubame computer of the Tokyo Institute of Technology. Then we tested with the NCI, run by the Australian National University, and of course, our tests here. Now, to prove the point, we agreed with our friends in Australia to try out a 10 gig connection they have to the US on the Pacific crossing cable. On the Southern Cross cable, I mean, sorry. And looping back, tromboning back from Seattle to Singapore on our 10 gig. And what came out of the testing? Again, the goal was to really see what it had. And we used genetic sequence data, send in the two directions using capacity on the A-Star Aurora and on the NCI computer. Now, 381 gig in one direction, 1100 in the other direction. Now, this is the only slides which are of importance. 8 minutes compared to 3 hours. 24 minutes compared to 9 hours. Now, if I'm thinking of our friends at Sesame in Jordan, I think it would be nice to multiply the effective throughput of the sometimes expensive capacity, even if it was by a factor of 4, doesn't need to be a factor of 10, that would be a slam dunk. I don't think we have to study and analyze for a long time the merits of such a proposal. Now, the dream is, if indeed this is possible, is it a good idea, or could we reverse the whole stack and say, okay, I will run IP over InfiniBand? So this is the next thing to try out, because here in the Middle East, I noticed international capacity is mightily expensive. Now, if I could multiply my effective throughput on that mightily expensive by a factor of 4, I would have a deal. Maybe we should start a business together to sell that to the industry. Of course, it's a game changer for the NRENs.
1 minute.
Sure. And the call of the HPC community to the ASREN, and especially the NREN members of ASREN, implement an InfiniBand network or subnetwork or software-defined network, whatever you call it, to satisfy the needs of HPC. because HPC is becoming more democratic. Everyone can now afford smaller HPCs, but the problem is you have to have them work together, and if we want to go